All right, this is Unit 1, Lesson 13, and we are in Chapter 6, Section 4 of the textbook. And this lesson is about the nth roots. So it means roots that are higher than the second power. Second root would be the square root. So we're looking higher than square root. So like the third root or the fourth root or the fifth root, etc. Our content standard that we're going to be looking at in this lesson is we're going to use the structure of an expression to identify ways to rewrite it. And we are going to be focusing on our mathematical practice of attending to precision, which means making sure we don't make errors as we work through the process of solving a problem. So in the past, we have done square root functions. We did that in our last lesson. What we're going to do in this lesson is simplify radicals, and we're also going to be using a calculator to approximate radicals. Our new vocabulary for this lesson, we have the nth root, the radical sign, the index, the radicand, and the principal root. Okay, our key concept, we're going to define what the nth root is. Sorry, my calculator program's opening up. Okay, so the definition. For any real numbers a and b, and any positive integer n, if a to the n power equals b, then a is the nth root of b. So for example, if negative 3 to the fourth is 81, then negative 3 is the fourth root of the number 81. And 3 is the principal root. It's based, negative 3 is basically based around the number 3. Okay, another key concept, real roots. Suppose n is an integer greater than 1 and a is a real number. If a is positive, so let's look at roots. So n is an integer. N is our root number. If it's an even root or if it's an odd root, that's what we're dividing up between. So if we have an even root and a is a positive number, there is one unique positive and one unique negative real root. If a is less than 0, then there are no real roots. If a equals 0, there is one real root. If n is odd, so we're doing an odd root like the third root or the fifth root or the seventh root, etc. If a is bigger than 0, if we're doing a positive number inside the root, we'll have one positive and no negative roots. No positive and one negative root if a is less than 0, because a is a negative number. And if a is 0, and we're doing an odd root, there's one real root. And again, I know all of this is confusing if you just look at a table, but it'll make more sense when we look at examples. So our first example, we have to simplify plus or minus the square root of 16x to the 8th power. So what we're going to do is we're going to essentially break this apart into the square root of 16 and the square root of x to the 8th. And they do it a little bit different than that in this video, but I'm going to spread it out over to the side. We have plus or minus, and I'm going to give 16 its own square root, and I'm going to give x to the 8th its own square root. And the square root of 16 obviously is 4, and the square root of x to the 8th, well, that is simply, when you take a square root, the square root is like the half power. So this is like x to the 8 to the 1/2 power. And when you have an exponent to another exponent, you multiply your exponent. So we're doing half of 8, 1/2 times 8, and that is how we get this 4th power down here. So it's pretty simple when you have square roots. It's a little bit harder when you get to higher power roots. Okay, so this time we have to simplify negative square root of q to the 3rd power plus 5, and all of that is to the quantity of 4th power. So when we break this apart, Bring up my drawing toolbar again. This is like saying the quantity q third power plus 5 to the fourth power, and then all of that to the 1/2 power. So again, we're just going to do 4 times a half, and we get 2, and our answer simplifies down right here. Negative q to the third plus 5 to the second power. 4 times a half is just our second power right here. Okay, part C, this time we're doing the fifth root. We're doing something higher than the second power root, the square root, not the square root. We're doing the fifth root. The fifth root is like we are saying something to the 1/5 power. So we're going to take the fifth root of 243. We're going to take the fifth root of a to the 10th. We're going to take the fifth root of b to the 15th. So this right here is just another way you can say the original problem. A to the 10th power. Sorry, my numbers got a little bit jumbled together there. B to the 15. Okay, so if you look up at the exponent table at the front of the classroom, I know you don't have this with you if you're at home, but the fifth root of 243 is just 3, because 3 to the 5th power is the number 243. A to the 10 to the 1/5 is 10 times 1/5, or 10 divided by 5, which is 2. B to the 15th to the 1/5 is b to the 15 over 5, which is 3. Here's our answer, 3a squared times b cubed. Part D, this is something just like we've looked at before. When we have a negative, remember that the I is going to come out. And so this is just going to be 2i, because the square root of 4 is 2, and the square root of -1 is I. Okay, here's some problems for you guys to check your progress on. Pause the video as long as you need. When you have your answer, come on back. Advance to the next slide. We're going to simplify plus or minus the square root of 9x to the 8th power. Answer this time is letter B. Part B, we have to simplify negative square root of a cubed plus 2 to the 8th power. Pause the video as long as you need. When you have your answer, come on back. Advance to the next slide. And our answer this time is letter A. Part C, we're going to do the fifth root of 32x to the 5th y to the 10th. Pause the video as long as you need and come on back when you have your answer. And our answer this time is 2xy to the 2nd power. And part D, square root of -16. Pause the video as long as you need. When you have your answer, come on back. And our answer this time is, of course, letter D, plus or minus 4i. Okay, moving on to example 2. We're now going to simplify using absolute value. So we need to simplify the 6th root of t to the 6th power. And your initial instincts might be that this is just simply t to the 6th, all of that to the 1/6 power, and that 6 times 1/6 is just 1, and so you might think this is just t, but I'm willing to bet that that is not just the answer by itself. Let's move on and see what they're going to do in this example. So it says, note that t is a 6th root of t to the 6th. The index is even, So the principal root is non-negative. That means it's positive or it could be 0. Since t could be negative, you must take the absolute value of t to identify the principal root. So the concept here is that since this is a variable in here, let me throw up a number example on here. If I had 2 squared and the square root of that, then the square and the square root would just cancel, and I'd just be left with 2. And if I had the square root of negative 2 squared, then the square and the square root would cancel, and I'd get negative 2. So, but each of these numbers, 2 squared and negative 2 quantity squared, each of those numbers is 4. So if I just wrote this one problem as the square root of 4, I don't know if my answer is 2 or if it's negative 2. And that's why in the past, in previous lessons, we've had to write plus or minus 2. So what they're saying here is when you don't know the value of this number, when it's just a variable, you're not sure if it's the plus answer or if it's the minus answer. You're not sure. But if you throw an absolute value around it, the absolute value of positive 2 and the absolute value of negative 2 is still just the number 2. So the concept here is whenever you have a variable and you're doing a root that's an even root, just throw an absolute value around your final answer. So here our answer is just the absolute value of t. Okay, part B, we're going to simplify the fifth root of 243 times x plus 2 to the 15th power. So you should remember that 243, the fifth root of that is the number 3, and the fifth root of x plus 2 to the 15th power is 15 divided by 5, that's the third power. So originally you might think that just this would be your answer, 3 times x plus 2 to the 5th power. But we're not going to stop just there, or are we? Since the index is odd, you do not need the absolute value. When the index is odd, when you have the fifth root, that's an odd number. When you have an odd root, you don't have to throw absolute value on. It's only when you have an even root. So that's just our answer right here. All right, here's one for you guys to check your progress on. We're going to simplify the fourth root of x to the 4th. Pause the video as long as you need. When you have your answer, come on back and go to the next slide. And our answer this time is C, obviously, because that's the only one with the absolute value. For part B, we're going to simplify the cube root of 27 times x plus 2 to the 9th power. Pause the video as long as you need. When you have your answer, come on back. Okay, our answer this time is letter B. We don't need the absolute value because the index, the root, is an odd number. All right, we're going to pick up with example 3 in the next video.